Tesla claimed he could make the entire planet ring with electricity like a struck bell and send power anywhere on Earth. This is that patent, in his own words. Be it known that I, Nikola Tesla, a citizen of the United States, residing in the borough of Manhattan in the city, county, and state of New York, have discovered a new and useful improvement in the art of transmitting electrical energy through the natural media, of which the following is a specification, reference being had to the drawings accompanying and forming a part of the same. The whole Earth as one giant circuit. It is known since a long time that electric currents may be propagated through the Earth, and this knowledge has been utilized in many ways in the transmission of signals and the operation of a variety of receiving devices remote from the source of energy, mainly with the object of dispensing with a return conducting wire. It is also known that electrical disturbances may be transmitted through portions of the Earth by grounding only one of the poles of the source, and this fact I have made use of in systems which I have devised for the purposes of transmitting through the natural media, intelligible signals or power, and which are now familiar. But all experiments and observations heretofore made have tended to confirm the opinion held by the majority of scientific men that the Earth, owing to its immense extent, although possessing conducting properties, does not behave in the manner of a conductor of limited dimensions with respect to the disturbances produced, but, on the contrary, much like a vast reservoir or ocean, which, while it may be locally disturbed by a commotion of some kind, remains unresponsive and quiescent in a large part, or as a whole. Still another fact now of common knowledge is that when electrical waves or oscillations are impressed upon such a conducting path as a metallic wire, reflection takes place under certain conditions from the ends of the wire, and in consequence of the interference of the impressed and reflected oscillations, the phenomenon of stationary waves, with maxima and minima in definite fixed positions, is produced. In any case, the existence of these waves have reached the boundaries of the conducting path and have been reflected from the same. Now I have discovered that notwithstanding its vast dimensions, and contrary to all observations heretofore made, the terrestrial globe may in a large part or as a whole behave toward disturbances impressed upon it in the same manner as a conductor of limited size, this fact being demonstrated by novel phenomena, which I shall hereinafter describe. What lightning revealed about the planet. In the course of certain investigations which I carried on for the purpose of studying the effects of lightning discharges upon the electrical condition of the Earth, I observed that sensitive receiving instruments arranged so as to be capable of responding to electrical disturbances created by the discharges at times failed to respond when they should have done so, and upon inquiring into the causes of this unexpected behavior, I discovered it to be due to the causes of this unexpected behavior. I discovered it to be due to the character of the electrical waves, which were produced in the Earth by the lightning discharges, and which had nodal regions following at definite distances the shifting source of the disturbances. From data obtained in a large number of observations of the maxima and minima of these waves, I found their length to vary approximately from 25 to 70 kilometers, and these results and certain theoretical deductions led me to the conclusion that waves of this kind may be propagated in all directions over the globe, and that they may be of still more widely differing lengths, the extreme limits being imposed by the physical dimensions and properties of the physical dimensions and properties of the Earth. Recognizing in the existence of these waves an unmistakable evidence that the disturbances created had been conducted from their origin to the most remote portions of the globe and had been thence reflected, I conceived the idea of producing such waves in the Earth by artificial means with the object of utilizing them for many useful purposes for which they are or might be found applicable. This problem was rendered extremely difficult owing to the immense dimensions of the planet, and consequently enormous movement of electricity or rate at which electrical energy had to be delivered in order to approximate, even in a remote degree, movements or rates which are manifestly attained in the displays of electrical forces in nature and which seemed at first unrealizable by any human agencies. But by gradual and continuous improvements of a generator of electrical oscillations, which I have described in my Patents Nos. 645,576 and 649,621, I finally succeeded in reaching electrical movements or rates of delivery of electrical energy, not only approximating but, as shown in many comparative tests and measurements, actually surpassing those of lightning discharges, and by means of this apparatus I have found it possible to reproduce whenever desired phenomena in the earth, the same as or similar to those due to such discharges. With the knowledge of the phenomena discovered by me and the means at command for accomplishing these results, I am enabled not only to carry out many operations by the use of known instruments, but also to offer a solution for many important problems involving the operation or control of remote devices, which for want of this knowledge and the absence of these means have heretofore been entirely impossible. For example, by the use of such a generator of stationary waves and receiving apparatus properly placed and adjusted in any other locality, however remote, it is practicable to transmit intelligible signals or to control or actuate at will any one or all of such apparatus for many other important and valuable purposes, as for indicating wherever desired the correct time of an observatory, or for ascertaining the relative position of a body or distance of the same with reference to a given point, or for determining the course of a moving object such as a vessel at sea, the distance traversed by the same or its speed, or for producing many other useful effects at a distance dependent on the intensity, wavelength, direction or velocity of movement, or other feature or property of disturbances of this character. I shall typically illustrate the manner of applying my discovery by describing one of the specific uses of the same, namely, the transmission of intelligible signals or messages between distant points. And with this, object reference is now made to the accompanying drawings, in which Figure 1 represents diagrammatically the generator which produces stationary waves in the earth, and Figure 2 an apparatus situated in a remote locality for recording the effects of these waves. The transmitter, a coil to shake the entire globe. In Figure 1, A designates a primary coil-forming part of a transformer, and consisting generally of a few turns of a stout cable of inappreciable resistance, the ends of which are connected to the terminals of a source of powerful electrical oscillations, diagrammatically represented by B. This source is usually a condenser charged to a high potential and discharged in rapid succession through the primary, as in a type of transformer invented by me, and now well known. But when it is desired to produce stationary waves of great lengths, an alternating dynamo of suitable construction may be used to energize the primary A. C is a spirally wound secondary coil within the primary, having the end nearer to the latter connected to the ground, E' and the other end to an elevated terminal. The physical constants of coil C, determining its period of vibration, are so chosen and adjusted that the secondary system E'CE is in the closest possible resonance with the oscillations impressed upon it by the primary A. It is, moreover, of the greatest importance, in order to still further enhance the rise of pressure and to increase the electrical movement in the secondary system, that its resistance be as small as practicable and its self-induction as large as possible under the conditions imposed. The ground should be made with great care, with the object of reducing its resistance. Instead of being directly grounded, as indicated, the coil C may be joined in series or otherwise to the primary A, in which case the latter will be connected to the plate E', but be it that none or a part or all of the primary or exciting turns are included in the coil, C. The total length of the conductor from the ground. Plate E' to the elevated terminal E should be equal to 1/4 of the wavelength of the electrical disturbance in the system. E'(CE) or else equal to that length multiplied by an odd number. This relation being observed, the terminal E will be made to coincide with the points of maximum pressure in the secondary or excited circuit, and the greatest flow of electricity will take place in the same. In order to magnify the electrical movement in the secondary as much as possible, it is essential that its inductive connection with the primary A should not be very intimate, as in ordinary transformers, but loose so as to permit free oscillation. That is to say, their mutual induction should be small. The spiral form of coil, C, secures this advantage, while the turns near the primary A are subjected to a strong inductive action and develop a high initial electromotive force. These adjustments and relations, being carefully completed and other constructive features, indicated rigorously observed. The electrical movement produced in the secondary system by the inductive action of the primary A will be enormously magnified, the increase being directly proportionate to the inductance and frequency and inversely to the resistance of the secondary system. I have found it practicable to produce in this manner an electrical movement thousands of times greater than the initial, that is, the one impressed upon the secondary by the primary A, and I have thus reached activities or rates of flow of electrical energy in the system E'(CE measured by many tens of thousands of horsepower. Such immense movements of electricity give rise to a variety of novel and striking phenomena, among which are those already described. The powerful electrical oscillations in the system E'(CE being communicated to the ground cause corresponding vibrations to be propagated to distant parts of the globe, whence they are reflected and by interference with the outgoing vibrations produce stationary waves, the crests and hollows of which lie in parallel circles relatively to which the ground plate E' may be considered to be the pole. Stated otherwise, the terrestrial conductor is thrown into resonance with the oscillations impressed upon it just like a wire. More than this, a number of facts ascertained by me clearly show that the movement of electricity through it follows certain laws with nearly mathematical rigor. For the present, it will be sufficient to state that the planet behaves like a perfectly smooth or polished conductor of inappreciable resistance with capacity and self-induction uniformly distributed along the axis of symmetry of wave propagation and transmitting slow electrical oscillations without sensible distortion and attenuation. 3 rules for making the earth ring like a bell. Besides the above, 3 requirements seem to be essential to the establishment of the resonating condition. First, the Earth's diameter passing through the pole should be an odd multiple of the quarter wavelength, that is, of the ratio between the velocity of light and 4 times the frequency of the currents. Second, it is necessary to employ oscillations in which the rate of radiation of energy into space in the form of Hertzian or electromagnetic waves is very small. To give an idea, I would say that the frequency should be smaller than 20,000 per second, though shorter waves might be practicable. The lowest frequency would appear to be 6 per second, in which case there will be but one node at or near the ground plate, and, paradoxical as it may seem, the effect will increase with the distance and will be greatest in a region diametrically opposite the transmitter. With oscillations still slower, the Earth, strictly speaking, will not resonate, but simply act as a capacity, and the variation of potential will be more or less uniform over its entire surface. Third, the most essential requirement is, however, that irrespective of frequency, the wave or wave train should continue for a certain interval of time, which I have estimated to be not less than 1/12 or probably 0.08484 of a second, and which is taken in passing to and returning from the region diametrically opposite the pole over the Earth's surface with a mean velocity opposite the pole over the Earth's surface with a mean velocity of about 471,240 The presence of the stationary waves may be detected in many ways. For instance, a circuit may be connected directly or inductively to the ground and to an elevated terminal and tuned to respond more effectively to the oscillations. Another way is to connect a tuned circuit to the ground at 2 points lying more or less in a meridian, passing through the pole, E prime, or, generally stated, to any 2 points of a different potential. The receiver, catching the Earth's echo. In Figure 2, I have shown a device for detecting the presence of the waves such as I have used in a novel method of magnifying feeble effects which I have described in my patents NOS 685,953 and 685,955. It consists of a cylinder, D, of insulating material which is moved at a uniform rate of speed by clockwork or other suitable motive power and is provided with 2 metal rings, FF prime, upon which bear brushes A and A prime, connected respectively to the terminal plates P and P prime. From the rings FF prime extend narrow metallic segments S and S prime, which by the rotation of the cylinder D are brought alternately into contact with double brushes, B and B prime, carried by and in contact with conducting, holders H and H prime supported in metallic bearings G and G prime as shown. The latter are connected to the terminals T and T prime of a condenser H, and it should be understood that they are capable of angular displacement as ordinary brush supports. The object of using 2 brushes, as B and B prime, in each of the holders H and H prime is to vary at will the duration of the electric contact of the plates P and P prime with the terminals T and T prime to which is connected a receiving circuit including a receiver R and a device D, performing the duty of closing the receiving circuit at predetermined intervals of time and discharging the receiving circuit at predetermined intervals of time and discharging the stored energy through the receiver. In the present case, this device consists of a cylinder made partly of conducting and partly of insulating material E and E prime, respectively, which is rotated at the desired rate of speed by any suitable means. The conducting part E is in good electrical connection with the shaft S and is provided with tapering segments FF prime, upon which slides a brush K, supported on a conducting rod L, capable of longitudinal adjustment in a metallic support M. Another brush, N, is arranged to bear upon the shaft S, and it will be seen that whenever one of the segments F' comes in contact with the brush K, the circuit including the receiver R is completed and the condenser discharged through the same. In illustration of the operation of the system, let it be assumed that alternating electrical impulses from the generator are caused to produce stationary waves in the earth, as above described, and that the receiving apparatus is properly located with reference to the position of the nodal and ventral regions of the waves. The speed of rotation of the cylinder D is varied until it is made to turn in synchronism with the alternate impulses of the generator, and the position of the brushes B and B' is adjusted by angular displacement or otherwise, so that they are in contact with the segments S and S' during the periods when the impulses are at or near the maximum of their intensity. These requirements being fulfilled, electrical charges of the same sign will be conveyed to each of the terminals of the condenser, and with each fresh impulse it will be charged to a higher potential. By impressing upon the Earth 2 or more oscillations of different wavelength, a resultant stationary wave may be made to travel slowly over the globe, and thus a great variety of useful effects may be produced. Evidently, the course of a vessel may be easily determined without the use of a compass, as by a circuit connected to the earth at 2 points, for the effect exerted upon the circuit will be greatest when the plates PP' are lying on a meridian passing through ground plate E', and will be nil when the plates are located at a parallel circle. If several such generators of stationary waves, preferably of different length, were installed in judiciously selected localities, the entire globe could be subdivided in definite zones of electric activity, and such and other important data could be at once obtained by simple calculation or readings from suitably graduated instruments. What Tesla claimed, power through the planet itself. What I now claim is 1. The improvement in the art of transmitting electrical energy to a distance which consists in establishing stationary electrical waves in the earth as set forth. 2. The improvement in the art of transmitting electrical energy to a distance which consists in impressing upon the earth electrical oscillations of such character as to produce stationary electrical waves therein as set forth. 3. The improvement in the art of transmitting and utilizing electrical energy, which consists in establishing stationary electrical waves in the natural conducting media and operating thereby one or more receiving devices remote from the source of energy as set forth. 4. The improvement in the art of transmitting and utilizing electrical energy, which consists in establishing in the natural conducting media stationary electrical waves of predetermined length and operating thereby one or more receiving devices remote from the source of energy and properly located with respect to the position of such waves, as herein set forth. 5. The improvement in the art of transmitting and utilizing electrical energy, which consists in establishing in the natural conducting media stationary electrical waves and varying the length of such waves as herein set forth. 6. The improvement in the art of transmitting and utilizing electrical energy, which consists in establishing in the natural conducting media stationary electrical waves and shifting the nodal and ventral regions of these waves as described. Please like and subscribe if you would like more content like this. Thank you.